Is AI lying to me? How is it making the decisions that it's making anyway? Today we're going to talk about the field of mechanistic interpretation and why it's hard to answer some of those questions, like why is AI doing what it's doing, or is it telling me the truth? But how mechanistic interpretation is going to offer us some hope to figure that all out. So in a traditional computer program, things do go wrong. There's bugs, problems happen. But as complicated as they are, there's always some way to go back in and sort of figure out why things happen the way they did if you put enough resources into looking into the problem. Not really the same thing with many of these AI models where you're not necessarily looking at code, but you're building something and then you're training it with data to perform a certain way. And you can go and look at this really complex model, which in many cases is a neural network, and it's not really obvious why things are happening the way that they are. These neural networks, they sort of are built off of the neurological structure in our brains. Not exactly the same, but sort of based on that model. And they can be quite large, so it's difficult to look into them and be able to get any sense of what's happening just because they're so big. But it's really important to understand what's happening in an AI system, why it's making the decisions that it does. There are real consequences to some of these systems. If an AI system says that you can't go on a plane if you don't get screened in for a job, you want to know why. If your autonomous vehicle pulls off the road and crashes, you probably want to know why it did that. But it's really difficult right now to figure out some of these things. So here comes mechanistic interpretation, which is going to try and help us solve this problem and figure out why these decisions are being made. Um, First of all, one of the things that it tries to do, and I'm grossly oversimplifying here, but it's trying to simplify what we're looking at. So if you think about a map of a country and you had every single city shown on that map, that's a lot of information to take in, and it's not really clear sort of where everything is. If we zoom out, instead of looking at every single city, we just look at the states or maybe the states and the capitals. It's the same data, but it's not as granular, and we're not trying to look at so many things at the same time. That's effectively what mechanistic interpretation is doing. It's taking this really complex network and it's zooming out a bit and making it much simpler to look at. There's a bunch of fancy math involved in that. I won't pretend to understand all of it. You could dig into it if you like. Now, with this new simpler map, what we do is we start isolating features. So, patterns of the network that are kind of firing together or working together on certain inputs. So, let's say we're looking at a picture and we're like, oh, okay, we see this area that turns on every time we see a wheel. And this area turns on every time we see a window. And then when we see a car, they're both on with some other things. So you sort of get these features that emerge in the network, and that tends to be something that researchers have seen consistently. Now, it's not always as straightforward and obvious as this, and it's not going to tell you what that feature means. But by isolating the patterns, you can then have a human come in and say, oh, "Okay, I see why this is happening in a certain way." So now back to the original question: how do we know what an AI system is doing, or even potentially if it's not telling us the truth? We can go back and look and see, okay, here are these features that happened at this same time, and that's why a particular action or output came out of that network. Now, the theory is that there would actually have to be some sort of feature for deception or lying in order for these AI systems built on neural networks to be able to do such a thing. So, if you can use mechanistic interpretation and look back in and identify these features, you could identify the feature or the part of the network that turns on when it's lying or trying to deceive you. And then you either know that or you can actually go in and manually disable that part of the network. So, I hope you enjoy it. There's lots more into it, but I tried to make it basic so everybody can access it. Thanks.